We'd like to thank the following sponsors for helping provide this video.
In the main event, I'd like to introduce Ajay Reddy, who will introduce our speaker, Dimitar. And I'm not going to try to properly pronounce his last name because I'm sure I'll butcher it, so I'll let Ajay do that. And thank you all very much.
Thanks, David. So, Dimitar and I have known each other for a few years now, and Dimitar is in my opinion, one of those coolest guys who knows, who has his feet in multiple different frameworks, and he is so adept at using the scientific method in project management. And I'm really pleased to have known him for so long. One of the things that when he first told me about this technique, the RBS technique, and he was chatting with me on Google Chat, and I was like, oh, I've seen this sort of things before, I'm not even going to pay attention to it because it's so convoluted. Well, as he sent me the slide deck, and as he started showing me some of these things, I started delving into it a bit more and more, and I thought, well, let's actually run some experiments on some data. So, well, I co-founded Scrumban, and so we have access to a lot of data with permission, of course, and we run some experiments, and we found some amazing correlation of estimations and actuals. And so that's when I was like, huh, this has some real value in working this thing. So Dimitar is a fellow LKU instructor. He, in fact, is a nominee of the Brickell Key Award. For those of you who don't know what the Brickell Key Award is, Lean Kanban University, the sort of the body of people who maintain the knowledge around Kanban method as applicable to knowledge work, sort of the David Anderson's, baby. Every year has nominations for the leading experts in our field, in process improvement and project management. And Dimitar this year has been nominated. So I hope he wins. So I will be introducing the topic as well, just to kind of lay the ground for the relevance of this topic. And as I do that, the topic tonight actually is embodied in my just up and coming book. So I brought up the first drafts of the copy. So if you guys want to just pass it around, you can look at it and let me know what you think. But I want to lay that ground for this topic tonight. And part of that is going to be talking about Scrumban and why this estimation technique is relevant. Why should we talk about this? Why should we pay attention to this? So, yeah. So recently, so there was a recent, those of you who follow Jeff Sutherland and David Anderson might have followed this conversation recently. This was, the father of Scrum, or the co-founder of Scrum, and the father of the Kanban method having a discussion about the two frameworks. And in this Twitter conversation, you'll see that, basically Jeff Sutherland is asking David Anderson, what's the evidence? Evidence of, hey, why Kanban was, someone asked why Kanban versus Scrum, and they pitted them against each other. And so both of them come to this conclusion that, hey, Scrum is one of many frameworks, Kanban is one of many frameworks, but hey, and Jeff ends with this thing, saying Scrum is one of many Agile methods used, it helps in complexity, I agree it's not the only way, but then he shows this graphic of version 1's study on which frameworks are most used in industry. And apparently, and I've used this in my book as well, apparently Scrum is, in this survey, 55% of teams out there use Scrum. And it's used as a case for, it's a successful, and it's popular, and hence it's successful. Or at least that's the argument some of us tend to make. What I like to show is the maker of Scrum, or one of the co-founders of Scrum, Ken, saying this, which is 75% of organizations who practice Scrum don't realize the benefits that they hope to get from it. And so, if that's the case, then what about the 75%? What is it that they're facing? What specific problems are they facing? Right? What are they encountering? And what should we do about them, right? And so this sits in the larger context of, hey, when they encounter the problem, what they do is they adapt to the problem and they just make accommodation for it. But as we found repeatedly in different, is that there are many such problems. And when we talk about Scrumban, what we're talking about is, hey, you encounter these issues in a Scrum context, whether it's estimation, whether it's identifying the team size, meeting your sprint commitments, so on and so forth. Well, there are other techniques that are available to you that you can draw from. And at the core, what we're asking for is a little bit of pragmatism and saying, apply the techniques that are available, whether let it be whatever method, whether it's the Kanban method, whether it's the A3, whatever scientific framework you have, pull from those techniques and apply where it needs to be applied. And in this particular context, and the way I describe Scrumban in general is the Kanban method applied to a Scrum context. So, some common problems that you see, right? Consistently broken commitments, forcing artificial team sizes, meetings taking too long, so you can name your pick, right? There's gazillion such problems. So one of those things is estimation. One of those things is estimation. So today, the reason we're talking about this stuff is how do we better estimate? Because ultimately what you're trying to do is reduce the risk from a business context in order to meet your commitments. It can give you a competitive edge, it can be various reasons, right? So in order to meet that, you can get better at estimation. What are some estimation techniques you know? Planning poker would be one of them, right? So can we get better at this? And what we're exploring today is a technique that is, funnily enough, was originally founded in horticulture. And we're bringing the learnings that were paper back from 1955 and applying that into knowledge work, the work that we do. So with that, I will hand over to Reddy.
So one of the biggest issues that we face as professionals is to estimate how big is our project. And I would like to emphasize here that when we asking how big, we are trying to estimate how much software we will have to build. And this quantification is referred to as sizing. So software sizing is different from software time estimation. Sizing is supposed to estimate the probable size of a piece of software, and delivery time estimation is supposed to estimate the time needed to deliver this particular piece of software. So the relationship between both is referred to as productivity. First of all, in what units of measure we will be sizing our project. Back in the days, they used lines of code, and then function point analysis was introduced, and FDA even made it to be codified in several ISO standards. But these days, Agile teams usually use t-shirt sizes and story points. So t-shirt sizing is very useful for starting sizing stuff, but its main disadvantage is that it is not additive. We cannot say our project is the size of our project is 5 M's, 2 L's, and 1 S, for instance. We cannot do this. That's why most of the people use story points, using Fibonacci number or numbers on exponential scale. I am, according to my code, at least, story points are about effort. And this slide is just to show us that if they are about effort, then the sizing will be equal with delivery time estimation. But since we put in the beginning that sizing is different from delivery time estimation, story points, if we equate story points with effort, it will not do the work for us. The easiest way is to say that story points should show only the complexity of the piece of software that we have to build. You know, because we have to estimate the probable size and not the effort needed. That's why we will not use story points as effort, but as a measure of complexity. So present day, no matter what unit of measure we use, function points, t-shirt sizes, story points, the way we size a project is to establish and analyze all the stories in a project, and then we sum them up and arrive at the total size of the project. This practice is time-consuming, and probably a great part of it will be pure waste because the requirements change. Some of the requirements will be dropped, new requirements will pop up, and if we try to analyze all of the stories, it's pure waste. So here is the question: how can we estimate the total story points for a project without prior identification, analysis, and sizing of every single user story? It turns out that actually there is such a method coming from Bakardzhiev. It was proposed by Jason in 1955. So it is a statistical technique designed to efficiently estimate the number of fruit in a canopy of a tree without counting all of the fruit. It is called randomized branch sampling. So mathematically, it's a multi-stage. It's used an estimator called Horowitz-Thompson estimator that is supposed to estimate the total number of fruit in the canopy of a tree without counting each and every fruit. It is used for structures which can be presented as a branch. A tree is really useful, easy to present as a branch, and in order to use randomized branch sampling in software development, it is useful to present a product backlog as a branching system. And it is not that difficult. If you imagine, right, the product backlog, let's say we have a fictitious product backlog that splits into epics. Let's say 3 epics. And each of the epics splits into user stories. That's the usual way we can know. And let's say the first epic A splits into 2 user stories, the second epic B splits into another 2 user stories, the third epic C will split into 3 user stories. So in total we have 7 user stories. application of randomized branch sampling, and this is something I should like write it. So we have a product backlog. And it splits into 3 epics. Epic A, epic B, and epic C. And let's say epic A splits into 2 user stores. Is it? Can you see from over there? No?
Yeah.
Okay, 1 and 2. I will just number them. B splits into user stories 3 and 4. And C splits into 5, 6, and 7. Yeah. So now, how can we estimate the total number of user stories just sampling? So it's a very simple product vector, right? Very small. But the idea is always the same. So we take one of the stories and we create a path to the branching system. So the path from user story 7 will be from the parallel backlog through epic C, user story number 7. Horowitz, the estimator, the Horowitz-Thompson estimator, says that one estimate of this branching system of the number of fruit or user stories in the branching system can be estimated by dividing the story points in this case. Let's estimate the story points. Let's say we have analyzed story point number 7 and we said it's 5 story points. That's our estimate. Using this estimator, we have to divide the number of the story points, which is 5, by the unconditional selection probability. So it is a sampling technique. We have to do it with sample at random. So we selected this story number 7, not just by picking it, we selected it at random. For instance, we picked at random one epic, this one, and then it has 3 user stories, and we pick at random one of them, which is in this case number 7. So the unconditional selection probability shows the probability for selecting this particular user story, which is calculated by multiplying the selection probability of the drug, which is in our case product backlog, by the selection probability of the user stories. We have 3 user stories, like epic, epic, by the selection probability of the user stories, which is 2 user stories. In our case, we have one trunk. So the selection probability for the trunk will be 1, right? No matter what we do, it will be 1. We have 3 epics. So the selection probability, if we assume it's a uniform distribution, we have equal selection probability, will be 1/3, right? Okay. And the selection probability of this particular epic, if we assume again equal probability, will be again 1/3, right? And make sure, no. 45 story points. That's one estimate. We don't know, like we have only one user story, and I'll definitely need the Excel sheet because I'll show you how can be done in Excel. So
We're working on it.
yeah. So this is one estimate, And because this Horowitz-Thompson estimator actually it's supposed to it does produce unbiased estimates. Unbiased generally means that if we average the estimates over all possible samples, the average should be identical to the actual value, right, for people who are kind of interested in math. So it is only one of our estimates. Usually, like it's a very simple branching system, product backlog. It's good to, I usually do between 7 and 12 statistics. And I'll show you next one. Which means that this one estimate, it doesn't work for us. We have to have at least 7, so that we can have create an average and then see what's the number of story points in the backlog. So the next estimate is the same. Like we pick at random one of the epics, and then analyze the epic, and then at random pick one of the story points from the epic, and using this formula, same formula, we will arrive at another estimate. And here, the answer is needed, but the good thing is that this technique can be used not only, and I'll show you it with Excel, it can be used not only with story points, but with, say, number of tasks per user story. There are teams that they break down the user story into tasks, and that may be the size of the project, say 100 tasks or 200 tasks. It can be used with any kind of attribute, including function points. If we analyze this story using function points, the calculation will not change. Like function point analysis is quite heavy for a backlog. Right? So the idea here is that with between 7 and 12 samples, we can come up with the total number of the size of our project in no matter the unit we use. Not only that, we can actually calculate in Scrumban. We are very interested in the number of stories initially. The same technique can be used, let's say, if we have a product backlog and we don't know how many stories we have. It's not about story, but just the number of stories. Using the same formula, right? If we want to, the number of stories is the attributes, as if that's the number of food on this particular bracket. So we can estimate using the same formula the number of story points. The number of stories, how this can be done. The same formula. We pick at random one of the, let's say epic. It has selection probability of 1/3. We break down only this epic into stories. Let's say we have 2. That's the number of food on this particular bar. And that's the selection probability. That's our estimate. The actual number is 7. If we take at random, let's say, at random, right, C, and then we break it down, then our second estimate will be epic C has 3 user stories. We have divided by selection probability 9. So 6 plus 9. Number of user stories. And if we are lucky enough to see my I'll show you an Excel file what we did with Ajay. With Ajay, we teamed up. When I come with this practice, because I'm running a very small software company and we don't have thousands of projects. I don't have statistical data. On top of that, we don't use story points. Or we size our projects in number of scenarios per user story. So that's our take, right? And I had no data.
Scenarios.
And I teamed up with Ajay and with the Scrumban team, and he provided me from their huge database of projects. He picked 13 projects. So he picked first Ajay project.
So every project that we picked had to have epic, story, and task breakdown. Our conditions were so every story that we picked had to have an epic, story, and task breakdown in the work breakdown structure. They had to be commercial projects, so it's not some pet projects of someone. So they had to be commercial customers. They had to be stable systems. In other words, so there's not a whole lot of churn in the system. So people leaving and people coming in, that would not be a stable team. So there were certain conditions that it had to meet in order to say that this is a good project to.
We picked only 13 out of all those projects that matched the criteria. We had 5 criteria. So we picked only 13 because I did it in Excel, and it is very labor just to format the stuff to fit into the Excel. The formulas are very simple, but the data, I spent lots of time on just formatting the data. So what we did, we compared for all those past projects, we ran RBS on each of them. And we calculated the story points for each of them. So here on the axis, we do have the story points estimated using RBS. On the y-axis, we put the actual. Because we do know the actual story points for each of those 13 projects. So, and it looked like that. Like this is 5,000, I believe, or 2,000, something like that. Story points, 0. And most of them like 100, let's say 1,000. And it
2,500 was successes.
Yeah. It turned to be like that.
So that's amazing correlation.
Yeah. And
So to get that sort of thing,
coefficient on
incredible.
correlation coefficient is which I personally was really surprised, right? It was really strange. And that was, first of all, visually, the correlation was visually like that, right? That's the most important thing when we look for correlation. It was visually there. Then I started removing some of the points just to see how it will move, right? Because there are cases, for instance, this particular point could make the whole correlation, right? But it was kept like that. And then what we did, the same thing, because the data from Ajay, it contained not only the story points per story, but also the number of tasks per story. And we did the same graphic. From here, on y-axis, it's tasks. Number of tasks estimated using RBS, and on the y-axis, number of tasks, 12 tasks. And the correlation coefficient was not that good. It is actually something like that. So you will definitely see it, right? And actually, my plan was to walk you through how it's done in Excel. Right? So, but the important thing is, first of all, from a mathematical point of view, is RBS as a sampling technique applicable to knowledge work. Right? Because if we think about it, a tree is a branching system, but the number of fruit is there, it is objective. If we count all the fruit many times, they will get counting error, but the number will be the same, right? That's obvious. With the product backlog, we don't have anything. It's intangible. We are sampling from, literally from what kind of universe we are sampling, right? There is nothing. And yet, statistically, actually, this sampling technique works. What is interesting, how RBS can be used? First of all, two main usages, right? First of course, is to estimate the size of your project. So with, let's say, 10 or 7 samples, you can know with a very, almost 100% sure what the size of your project will be, which is very useful. But the second thing is maybe more useful, right? If you have a team, and you have statistics for this team, just the number of stories, user stories that they establish, the story points per user story, and the number of tasks. And using RBS, we can say if the team actually consistently applied a certain methodology for breaking down the epics into user stories and for sizing those user stories in some units, right? Which is very important. So my hypothesis is, so here are the correlation results. These are all the story points. 13 projects, very small, less than 500 story points. One very big, around 2,000. And then the number of tasks. Yeah, the correlation coefficient is not that good, right? But it's almost like it's.
And the interesting thing is, all of these projects are from varied domains. They're from different countries and very, very different domains. Education, finance, very, very different domains. So even startup companies. So to see that correlation across those different domains is very interesting.
So I want to emphasize this is the main question, right? Without statistical data, all RBS technique is like we are sampling from the air, literally. So my hypothesis is that the assumption behind using RBS for software development is that the project size depends on the context, which is the customer, the people developing the project, and the methodology those people are using for managing the requirements, breaking down the product into user stories, and sizing each of the stories. No matter what methodology they use. They may use planning poker, behavior-driven development, feature-driven development. No matter what. If they apply consistently a methodology which is coherent and explicit, then the results should be there. So it is mathematically sound to use a sampling technique for sampling intangible things. And I once I think, like, for instance, like let's have a plane, like plain field with nothing there, and we just move, let's say, people from Boston to settle there, and we provide them with the same building codes that were used in Boston. So we put the same constraints. So using RBS, we can actually estimate the number of houses that will be there. As strange as that, right? Really strange. So that's our conclusion. So those 13 projects, the people that worked on them, they applied consistently a methodology for breaking down the product backlog and sizing. Yes?
I have a question. In order to use this to estimate product backlog, do you need to start with all the stories written for that backlog?
No, I'll show you. No.
Oh, all right.
Let me just.
It's done
Uncle.
Thing like that again.
So,
I have a question that could be without the slide.
yes.
I was wondering what made you think of doing this in the first place? It's fantastic.
The truth is that actually I was thinking how to. So the long story short, last year I modified a forecasting technique using bootstrapping and Monte Carlo for estimating delivery time for a project. And it is really useful. The major obstacle is that actually in order to use this technique, I had to know the number of user stories. And for a big project, let's say 300 user stories, there is no way to know initially the number, right? Without analyzing and breaking down all the epics into stories. So that was the main obstacle. And somehow I started thinking, most probably there is some technique that people are using in a similar context. And I started thinking about counting apples on an apple tree. It turned out that actually Jason, who was from Iowa, he was an American, applied it to orange trees. But the idea is the same. And I somehow, by accident, found an application. These days, RBS is not used that much in horticulture. That's what I found, because they use very specific, very involved software-enabled devices. They take images, and based on the images, they count the fruits. Right? They don't use sampling techniques. Right? So I'll use the time just to show you the Excel, because I'm not sure how long it will be here. Right? So this file contains those 13 projects that came from Scrumban. So they are their number 9, 10. So here are the results. So all the slides are showing the results. So I'll show you how actually it's being done in New York. So here in this this part, that's our raw data. That's the data for the real past projects. What we have here in column R, it will refresh soon. Yeah. In column R, we have all the epics number. That's all. We know only the number of epics. In column S, we have the stories per epic. You see, for the first epic, we have, let's say, I believe 10 stories or so. So I'm not sure. 14. And we have the estimated story points for each.
Can I ask a question?
Yeah, so let no, please wait. Here are the 7 samples that I took, right, at random. So it's very important to take the samples at random. What I did, I generated 7 random numbers between 0 and 1 for the epics. So I will be selecting 7 epics. That's all. Out of, we'll see how, the total number of epics is 20. So we have 20 epics, and I'll sample only 7. So I generate 1 random number. In this case, you see here, so that's a random number. It's less than 0.1. I go into our data, and I'm looking for which epic, actually, this random number will pick me. And it is, for each epic, I have calculated the selection probability, which is which is easy to calculate because we divide this like the number of epics we have was one divided by 2. So for the random number of less than 0.1, it is the epic number 2. Right? At random, I pick one epic, and I put here, and I put the number of epic here. And then I go and break this epic into user stories, only this one. And I find it's like easy because I go to the past data and I see that this particular epic is broken down into 14 user stories. And then I generate a new random number to pick a user story, one of those 14. And in this case it's 0.7577. And I go and I look which of the user stories for this particular epic number 2 will I have returned based on this random number. And here in this column T is the story selection probability, which is really 114, right? Each of the user stories, because we have 14. And that's the user story. That's the selection probability, and that's the user story that I select. And I go and I find the estimated story points for this user story, which is 5. And based on the estimator, I find that based on this sample, the estimated number of story points for all 20 epics is 1400. That's the first estimate. And then I go and start with the second epic. Right? It is epic number 14, based again on the random number. The most important thing here is that we should select at random. That's crucial, at random. And we at random, I selected back then epic number 10. And I go and see how many user stories this epic was broken down. And it's broken down in 10 user stories. And then at random, I pick one of the user stories, only one, and I analyze it by looking into the past data. And I see that it is one story point. And using the same formula, it looks like that this time the estimate is 200 story points for the whole vector. And then we go to the third epic. And we pick the third epic at random. And then we break it down. And then we pick at random one of the user stories. Analyze only one. And we find, like again, one story point. And the new estimate is 260. So eventually, we select at random 7 epics and only 7 user stories. And we estimate only 7 user stories out of 176. We pick only 7. And we analyze them. And the number, like the real number of story points is 573. And our estimate, the average of our estimates out of 7 estimates is 500. So we have a difference of about like 12%, 13%, with only 7 user stories analyzed. So we do this for all 13 projects, and that's the result. See? So if you have time, you can take your past data and just go and check at least if the methodology that you applied is consistent. You have to have similar results. Yes? Questions? Anyone? No? Yeah?
Yeah, one thing that occurred to me while you were talking about this was that I could see how this would be really intuitive if you had a true random distribution. But we're talking about sloppy actual development organizations where maybe the distribution is way far from random. And so, as it becomes less balanced, does this modeling become less accurate?
Distribution of what?
The distribution of stories within epics, within projects. You know, it would seem to be logical that if, you know, every epic had roughly the same, you know, even a randomized, which eventually comes out of the wash, number of stories, then yes, I could see this predictive model being very accurate. But let's say in the real world, you had a wildly divergent number of stories per different epic, and you happen to choose the wrong one, you might get a completely different answer that wouldn't really reflect the actuality of
Yes, and so to answer your question, so the question is actually, that's the number of user stories for this particular project. You see, it ranges from 6 to 14. It's highlighted. Even like it looks like completely random, right? But there is no way for us to know, right? How could we know? The thing is that it's the data shows that there was something. Obviously, because it's the correlation coefficient is like almost like 1. It's very high. It looks, so my theory again is that this particular project, the number of stories was not picked at random. So when the team sat down and started analyzing and breaking down the epics into stories, they followed some methodology. They didn't do anything at random. They put some effort and they followed some line of thought, which is presented in the end result when actually we can sample the actuals pretty close, 13%. And this is done in the matter of just a second, of 10 minutes.
I was just raising my hand so they would bring the microphone.
Okay. So the thing here is this is just a technique, right? First of all. But in some contexts, in my context, it's really useful because usually when clients come to me and they ask for almost a commitment, right? An estimate which almost most of the time is commitment, and I can size a project in a matter of 15 minutes, or let's say 1 hour. It depends on the number of user stories per epic, right? Because if we have to break down an epic into 30 user stories, it takes time. Yes.
So I just want to make sure I understand the sequence of events, if I can summarize it correctly. Tell me if this is a correct summary. We're thinking of our project. First, we have to identify all the different epics we believe are in the project. Once we have those epics, we do the random number generator, and let's say it lands on epic 3. We then further do analysis on epic 3 to identify how many stories we think are in that epic, and then we, by a random number, land on one of those stories, and then we do analysis of that single story using whatever methodology we've been using in the past, whether it's story points or planning poker or whatever.
Yes.
And so the total sum of the work, as I understand it, is identifying the number of epics, identifying the number of stories in the selected epics, and then analyzing the story points or other methodology of those
Yes.
stories inside that epic. Is that?
Yes, that is correct. So here is the algorithm actually. Again, so we divide the project into epics. That's mandatory. If we have to divide it into 100 epics, we have to do it. That's the technique. Right? The second step is randomly sample one of the epics. And then we analyze how many stories are in this particular epic only. And we just write we write down the number of user stories. And then we randomly sample one of those user stories. And we estimate the story points for this particular story. And then we using the formula, the Horowitz-Thompson estimator, and we do one estimate for the total story points for our paper. That's only one estimate. And then we repeat points from 2 to 6, let's say 7, 12 times, it depends. And then we take the average of our estimates. That's the algorithm. Yes?
So, the woman over there with the microphone.
Oh.
Hi, I can see and understand in a sort of an intuitive way where you're coming from, and the fact that because at least you're counting in this sort of hierarchy from backlog to epics to story points and possibly even to tasks, when you're ever looking at something at a bottommost branch, you're still taking into account some probability from some of the other upper levels. And that's what's making this whole thing work. But the other part that you mentioned that's making this whole thing work is the idea that the team is applying something consistently. And as someone behind had mentioned, we have a lot of cowboys out here in the United States. That's a good way to put it. And they don't always estimate either the same way or don't necessarily even calibrate with each other. So in the practices of the organizations that you've applied this to, where this works, can you give us some ideas of what kind of discipline or how they calibrate with each other so that they can actually rely on a method like this?
So in this particular case, these organizations are from different domains. So but they all have some things in common. And some of the things in common are they're all managed projects. They have a fairly steady release history. There's a fairly steady release history, and they're stable in that there's not a whole lot of churn. There's not team members going in and out. They've been coached. They had some coaching behind them. So there's some commonality to them, but they don't know each other. They're all different, different domains, different industries. So
I just meant different commonality of discipline or thought practice as opposed to domain or anything else.
Within each team there's commonality of their estimation. So they understand each other's. They have a history with each other.
And so the root question then is, how did they develop that history?
Yeah, over time, right? So they had a stability behind them. So that is true. So it's not like a random team that's, to your point about cowboys coming together and now suddenly applying this. So there's a stability behind that.
Thank you.
Okay, the woman over there with the microphone.
Hi. So it doesn't really surprise me that much that you see this kind of correlation with past data, because that is at a point where everything's already been broken down and analyzed, and as you're saying, if the team is applying a consistent method, then things should come out similarly. But it seems like this is highly dependent on knowing the right number of epics at the start of a project. And I'm actually just curious from Agile practitioners if you find that to be the case, because sometimes you have an epic, but then once you start analyzing it, that's really 2 epics. Or, so I'm just wondering, in the real world, how often the number of epics at the beginning of the project is really what it ends up being. Because if you don't know the number of epics at the start, then I don't see how this will work.
Well, this is just a technique, right? It's not the silver bullet. It's not supposed to save the world, right? But if in certain circumstances, it saves time, a lot of time, because we have to analyze only 10 stories. Like, you are correct that the epics, we have to establish the epics. But usually the epics are not that many, right? Maybe 20, 30 for the project with 2,000 story points. Let me just see which one was this. How many epics did they have? It's not this one.
But that's past data. How often are you finding that the number of epics at the beginning is pretty accurate?
So that's a fair question actually. In my practice, it happens not all the time, but it does happen. For instance, I size the project using this technique, right? And let's say it's like my projects are not that big, around 20 epics. And 1 month into the project, the client comes and says, well, I need a new functionality which actually is a new epic, right? It's quite big. And I start from scratch, right? I add the epic, I change the selection probabilities, I sample again, right? Because the context is changed, right? And then I will find the new size of the project, right? The easiest way is that if we have only one epic, and we break it down, and it's like it's 3 user stories, right? So just analyze those 3 user stories, right? And add it to the size of the project, something like that. So again, it is not something. It's just a technique, right?
And generally speaking, the variation in epics is far less than the variation in stories. So, I mean, it's yeah.
I think the larger point too is if the number of epics is wrong, any other project estimation thing will also be wrong.
Yes.
So
Yeah.
any other way you're estimating the project will produce a similarly bad result. And so, as Dimitar was saying, you adjust as you learn more information.
Yeah. So we have a question. Oh yeah.
Do you have any heuristic in terms of the number of ranges you have to sample based on the size? I imagine for smaller things, you don't need quite so many. For bigger, you need more. Is there a percentage range, or is there some other thing that you sort of look at a thing and figure out how often you have to make that deep dive to get the really accurate estimate?
No, it's not about purity. The important thing here again is that we sample at random. That's crucial.
Sure. I get the randomness factor, but if you sample 5 when there's like 5,000, that doesn't seem like it would be a reasonable enough sample.
Yeah. So yeah, I got the question.
So that's my question.
Between 7 and 12, that should be enough to produce like a good average. That's
So you're saying it's not like a certain percentage?
no, it's not.
of the pass?
It's like
Interesting.
it's like a sampling. Yeah, so let's say you have an urn full of with rocks, and there is no need to sample all of the rocks, right? You have to sample a certain amount of rocks, no matter how big the urn is, right? So it's the same statistics. So usually a statistic is between 7 and 12 samples are enough to establish a distribution, right? To be able to say if this distribution actually could be normal. So between 7 and 12. Yes.
Hi, I'm a little curious about something. I thoroughly understand how this works for looking at historical data. But in your algorithm at step 5, you have the team estimating a single story. How much do you find the teams knowing you're using this algorithm affects how they size that story? Psychologically, if I know, hey, this one story, sizing this story is going to impact the entire idea of how big this project is, more so than if I had been doing, 300 stories, right? I'm only doing one. How much does that impact their estimation on that story?
So that's a very good question. My experience shows that there is no impact. Absolutely, because actually nobody knows the final number, the final result. Like it's just a user story. I showed you that, for instance, see the correlation here for number for the project number 9. See this particular user story. See this one. It is one story point, but the project actually, the size of the project is 500 story points. So, and we sample only 7, right? From 1 to 500, it's a big, quite like a leap, right? So a human being to extrapolate, right? But it depends on the practice. I tried it once in a different way. So I had the customer next to me, and I said, based on your list of requirements, I established a certain number of epics, with big chunks of functionalities, right? And because I'm using scenarios, and I said, would you help me for an hour, just to analyze seven small cases out of the whole project, and for me to actually come up with the estimate for the delivery, right? And using the customer, I randomly sampled several, like 7 stories, and the customer spent time analyzing in details the scenarios for these 7, which is impossible to get the customer sitting for days, right, analyzing all the users, right? So I used this in this way. The customer was absolutely not aware how I will use the number, right? But it was a good exercise because you go into how she thinks and stuff like that. So again, it is just a technique, right? It mainly depends on the context. Again, the context is everything in this case. But for a stable context, it should produce like stable results. My hypothesis is that if you run, if you have past data, and I'm sure you have, if you run it, you can actually see how mature is your team or your teams. It's just by using this you can judge how mature they are. Are they cowboys or not? Right? Which is again useful, and it takes like maybe 1 hour for on average, because we are looking between 7 and 12 stories, right? So it's not a big investment of time, and the correlation is stunning. I was really surprised because it's almost impossible, right? I mean, and we have the same correlation for the number of tasks. A bit worse, but it's it means that those organizations that Ajay they have in Scrumban, they do their job properly. I mean, they are not robots. It's useful information. You can. I was actually thinking about, for instance, if you have a team that actually is supposed to be trained in a certain technique, let's say planning poker, and you can run like not a real project. You just give them a fictitious project, say estimate those 7 stories, right? Next one. And in a matter of several hours, they may estimate 12 projects. And you can judge how consistently they apply this particular technique, methodology, which is planning poker. Do they put effort in it, or they are just coming out with random numbers, right? So the possibilities are endless here. Literally, but it's always with the math. Always this the case with the math.
You could use historical data too, right? If you knew it was one story point, you could look at historical things.
So you could use historical data, right? If the estimate was this is 2 story points, you could look, rather than avoid the bias that this gentleman talked about, you could go back and look at other things that had 2 story points and look at the actuals from previous things that had 2 story point estimates, and simply plug the average of those numbers in for Monte Carlo that.
Right. But again, it's a statistic. The idea behind sampling is that by sampling we can learn about the universe, right? With a very few samples. That's the general idea.
Time for one more question.
Yeah, okay, one more question. Yes?
Right, I guess what I wanted to do is just underscore a point you made a little bit earlier, and that is around having a team that knows how to produce consistently. So if you think about it, what we're talking about is having a team that's worked together for quite a while. They've been through several projects together. There's a set of minds that tend to think the same way all the time. So you've got a well-oiled human machine. If if you have a machine, then you can feed any sized input and it's going to produce at a predictable rate. So that's really what this is all about. You take RBS, and all that's really allowing us to do is to take a look at the input, but not have to do a deep dive on everything. All you really have to do is, with the same set of minds as always, define a set of epics as they have been all along, and only drill down into those enough to get a decent sample and create a reasonable estimate. But what you can't allow is a company to come along and say, here's a new project team, I need you to go off and give me an estimate.
Right.
You can try it, but you're not gonna have a very high confidence
Yes,
level.
yes, that is correct.
That's
Actually,
exactly
this,
right.
this may be the scientific justification of Agile, right? Why we in Agile, we want to keep the team together, right? That's the scientific justification. It's statistically proven right now that you have to keep the team together for a long time to get consistent results. So, my time is up, I believe. The Excel files and the slides will be available on the